Hello, can you hear me?
Yes, ma'am.
Okay, so today we will have a small introduction to likelihood ratio test because technically in the recorded lectures we have finished the theory for multivariate normal distribution. Okay, but now we have to go for testing of hypothesis. So just like in the univariate setup, even in the multivariate setup we like to have different kinds of tests. So today we will see some basics of testing of hypothesis. You already know those, but we'll revise those and then we will see likelihood ratio test, how it is defined, etc. Because in the multivariate setup, many tests can be derived via likelihood ratio tests. We will see a few examples in the class and that should prepare you for generating or creating your own likelihood ratio tests. Okay. So first question, you can see my screen, right?
Yes, ma'am.
Yeah. So, first of all, what do you do in testing of hypothesis? In general, univariate you have seen many tests. So, what is the aim of testing of hypothesis problem?
Hello, ma'am.
Yes.
Ma'am, hypothesis is nothing but an assertion. So,
Mm-hmm.
in the procedure of testing, we actually try to test the assertion of the claim which has been against some particular counterclaim. The claim is known as general known as the hypothesis and the counterclaim known as the hypothesis. So, actually, test that the
Okay. Let me talk about univariate setup. Uh, I want to claim, I'm trying to use your terminology. I'm a manufacturer of certain drug and I want to claim that my medicine cures headache in 15 minutes. Means as if you take my tablet, then within 15 minutes your headache will go away. Okay, this is the claim I want to test. So what should be my null hypothesis and what should be my alternative hypothesis? Others are also welcome to pitch in. He should not be the only one who answers. I want null hypothesis and I want alternative hypothesis. I don't understand the words like distribution. Okay. What about others? Do they agree with what he said or do you want to change? You want to give different answer? Okay, so this is actually the slippery area. See, that's why I gave this example. When you said claim and counterclaim, you should always remember that generally, whatever you want to establish should generally be alternative hypothesis, not the null hypothesis. Okay, this is not emphasized in BSc, so it is not your problem that you don't know this. But research hypothesis or the hypothesis that you are interested in should generally be alternative hypothesis, not the null hypothesis. Okay, because rejection of null hypothesis is very strong. Hence, your claim can be established only if you have strong evidence. So, strong evidence against null. Okay, so in this question, when I said that my claim is my drug cures headache within 15 minutes, I am saying within 15 minutes means in less than 15 minutes, correct? Headache in less than or equal to 15 minutes, then or strictly less than 15 minutes. Within 15 minutes means if you want you can make it 16. Then my alternative hypothesis will be mu less than 15, and then corresponding null hypothesis will be mu equal to 15, or some books write it as mu greater than or equal to 15. Okay, so my alternative has to be this. So in any kind of research, you are interested, the hypothesis in which you are interested, hypothesis which you want to claim is true, should be your alternative hypothesis. Okay, see, there have been debates. In fact, the results would change if you change your definition of null and alternative hypothesis. But an ideal way of doing research is to take your take your hypothesis of interest as alternative hypothesis, because if in that scenario, if you conclude that you are rejecting your null hypothesis, then it would mean that you have a very strong evidence in support of your alternative hypothesis. Okay, because rejection of null is made very difficult. Okay, we use type 1 error as we have type 1 error upper bound as 5%, correct? So rejection of null hypothesis is comparatively difficult. So if you can do that on the basis of the data, then it means that you have a strong support for your alternative hypothesis, and then you can claim that your hypothesis is correct. So generally, your research hypothesis should be taken as your alternative hypothesis. Okay, so if you want to claim less than 15, then your alternative hypothesis should be less than 15, and null hypothesis will be equal to or greater than or equal to 15. Okay, let me take another example. So suppose you have, say, products coming from two companies, company A and company B, and your claim is that company A produces less defective products. So number of defective products produced by company A is less. This is your claim. Then your alternative hypothesis will be proportion of defectives for A company is strictly less than proportion of defective for B company. This becomes your alternative, and then you propose null as complementary part of that. Okay, so this becomes greater than or equal to PB, or some books write it as equal to PB. Okay, so alternative has to be your hypothesis of interest. This should always be the case. You cannot take your hypothesis of interest as null hypothesis, and if it does not get rejected then you are happy. That should not be the case, because rejecting H0 is something very difficult. So if you want to really be sure that what you have like your claim is correct, then you should phrase it in such a way that your claim is alternative and you are rejecting H0 means you have a significantly good proof, you have very strong evidence against null, which is in favor, against null means in favor of your hypothesis. Is it okay? For some of you this may be very trivial, but for many of you this may be something new, or something little uncomfortable to digest. But are you getting my point? Okay, so this is always the case. So whenever you are talking about testing of hypothesis, your research hypothesis or hypothesis of interest should be framed as your alternative, and then null should be taken as complement of that. Okay, okay, and I hope everyone knows type 1 error, type 2 error, p value. Everyone comfortable with those concepts? What is p value? In testing of hypothesis, what is p value? I don't understand tail probability, because tail means again left tail, right tail, both tails. And why tail probability? Tail probability is not an interpretation. You are telling me formula. I want interpretation. Others. What is p value? No. See, correlation wise, it is fine. Means p value can be considered as an indicator of your degree of confidence in null hypothesis, but by formula, it is not that. By formula, direct p value interpretation is not probability of null hypothesis being true. That is not the case. So, what is the interpretation? Yes, I mean, I got your point. If your p value is less, then you are more likely to reject the null hypothesis. But yes, but that doesn't mean that p value gives you simply probability of null hypothesis being true. That is not the case. Others? There are 26 people in the class, so 25 people excluding me. Out of them, only 2 have talked. What about others? Sorry? Someone said something, but I could not hear. Can you please repeat? Okay, extreme observed result means what? You're going close, but I need more precise words. Again, interpretation. You are telling me formula. This is procedure. I want interpretation. You are telling me procedure. When to reject, when not to reject. No, that's what I said when Pranita also talked. You can't say it is probability of H naught being true or probability of H naught being false. No. You don't. H naught is not an event. I mean, you don't know the distribution of H naught. You don't derive something like distribution of H naught. If you know distribution of null no. Level of significance is always alpha. Level of significance won't depend on H naught. Level of significance is alpha. Why would it depend on H naught? Least significance level and level of significance are different. You are trying to say p value is that value. P value is the smallest value at which H naught can be rejected. But that is again a formula. That is not interpretation. See, you have been saying probability of H naught, etc. But H naught is a statement, mu equal to 0. So mu is either 0 or mu is not equal to 0. There is no probability associated with it. You can't say probability of H naught or probability of H naught being accepted or probability of H naught being rejected, because H naught is not a random variable. H naught is a statement and it's just mu equal to 0. So mu is also not a random variable, or anyway anything like mu equal to mu naught. mu is not a random variable, so it is either true or false. There is no probability associated with it. Probability has to be of some random quantity, right? It can't be of some constant quantity, and parameter is constant even if it is unknown. Yeah, that's what someone else also started saying, but exactly what? I think Yogesh was saying this, right? Probability of extreme. These words Yogesh also used. But extreme what? Yes? Mm-hmm. Okay. Okay, you're almost there. A couple of crucial words are missing. Hmm. Correct. Correct. So, see, let me try to explain what he's saying or what I was expecting. Okay, suppose this is mu naught. Okay, suppose this is mu naught. Your sample mean is somewhere here, let us say. Okay, your sample mean is somewhere here, and you are trying to see whether this is justifiable. Means if my, so my h naught is suppose mu equal to mu naught. Okay, so you are trying to see that if my null hypothesis had been true, means if my population mean is actually mu naught, can I get this x bar as a sample mean? Probably I can get. Okay, now I ask you, okay, can I get somewhere here, can I get this x bar as a sample mean? What you would say? If I want to compare these two x bars, let me call this x1 bar and x2 bar. So which is x1 bar more likely to occur or x2 bar more likely to occur if my population mean is mu naught? Correct. X1 bar is more likely to be a sample mean if population mean is mu naught. And sample mean is a random quantity, so I can talk about its probability. So I can say that yes, probability of sample mean being equal to x1 bar is higher than probability of sample mean being equal to x2 bar if my mu naught is true. I mean if my h naught is true. Correct. So p value is something similar. What you do is, you know the distribution of the test statistic, and let us assume that we have z test. So my distribution of the test statistic is standard normal. Assume that this is the standard normal curve. I know it is not, but assume that this is the standard normal curve. So you have 0 here. Okay, then you know that under h naught value of the test statistic is anyway 0. Correct, because for z test, if my h naught is say mu equal to mu naught, how do you define test statistic? You define test statistic as x bar minus mu naught divided by something, standard error of x bar. Am I right? Okay, so if my x bar itself is mu naught, then no worries, my test statistic is 0. But of course in real life you are not going to get x bar equal to mu naught exactly. Now you try different values. So what you know is, if h naught is true, then this test statistic mod, let me take mod, so because we are talking about say two-tailed, so if h naught is true, then you know that x bar minus mu naught should be as small as possible. Okay, so as you go away from 0, means as x bar minus mu naught upon this standard error, as this quantity increases in magnitude, then you know that it means that h naught is probably false if this becomes very high. Okay, so suppose your observed value of the test statistic is somewhere here, t observe. Okay, observed value of the test statistic is somewhere here. This curve is your distribution of the test statistic under h naught. Okay, this is called as null distribution of the test statistic. So in Z test it will be standard normal, in ANOVA it will be F distribution, etc. Okay, so this is null distribution of the test statistic. Okay, now okay, so suppose my observed test statistic is somewhere here. Now I want to see that if my null hypothesis were true, means if this were actually the distribution of the test statistic, then how probable or how likely is it to get this value, or how likely is it to get either this value or a value more extreme than this. More extreme than this means either in this region, or if I am considering mod, then in this region, because magnitude wise more extreme. Okay, so if my null hypothesis is true, then how likely is it to see such an observed value? See the analog. Suppose let's say you wake up in the morning. Okay, you wake up in the morning, you open your window and you see that the soil outside your house is completely wet. Then what do you feel? What is your conclusion from that when you see the wet soil? Probably it rained, correct? Probably during night it rained, or probably early morning it rained. Okay, now suppose let us say that you have not yet, I mean you don't have any other way of inferring whether there was rain or not. So if you see wet soil, then you will say yes, probably it rained. But if suppose the entire soil around your house is completely dry and still your mother tells you that there was heavy rain and you didn't notice at night, are you going to believe her? No, because your data that you have currently in front of you is that the soil is not at all wet, and what you expect is, if what she is saying is correct, if actually there had been a heavy rain, then you expect that soil to be wet. Maybe you go ahead, see some patches of wet soil, then you start believing, okay, probably. So it is something similar here. So if H naught is true, then generally you are expecting values somewhere here, somewhere near H naught. Okay, so if I am getting an extreme value, I would like to find how likely this value is under H naught. Means, had there been heavy rain, still how likely is it that by now, by the time that I have gotten up, the soil is completely dried up? How likely is it? If suppose you have gotten up at 4 o'clock in the afternoon, and if your mother is claiming that there was heavy rain around midnight, then probably you have to believe her that maybe during the day it got dried up. But if you are waking up at 6 o'clock and if your mother is claiming that there was heavy rain and if you see no wet soil, then probably you won't believe her. So depending on the current observed value, you would like to see how likely is it that I am getting such a bad value or such an extreme value, or even something more bad than this, worse than this, if H naught were true. And that is what p value is. And if those chances are very low, means if under H naught getting a more extreme value, getting as or more, you consider current value as well as more extreme. So getting as or more extreme value, if this is very unlikely, then you will say that okay, H naught is probably false, so let us reject H naught. Okay, so this very unlikely means your p value, that is the probability of getting a value more extreme than the current value or as extreme as the current value, is very small. Very small means maybe less than 0.05. Then you will say that okay, let us reject H naught, because H naught is very unlikely to be true. So it is like you got up at 6 a.m. and your mother is claiming that there was heavy rain around midnight and you see almost no wet soil. Then you are going to say that okay, your mother is probably lying to you for some reason. Okay, so why? Because you know that if there had been heavy rain, then seeing dry soil at 6 a.m. in the morning is almost impossible. So p value is probability of that, probability of seeing dry soil when you get up even at 6 a.m. if there had been rain. So that probability is very small. Hence, you are more likely to conclude that your mother's statement is incorrect. Okay. Same thing you are doing here. So if under H0, probability of getting something as bad as what you have observed or worse than that is very low, then probably H0 is wrong, and hence you are observing something which is very unlikely under H0. You are observing it. If it is unlikely, ideally you should not observe it. You are observing it even though it is unlikely under H0. It means probably H0 is false, and hence what you are observing is not as unlikely as H0 is saying, and hence it has happened. Because it is not unlikely, it has happened. Is it okay? So that is p-value. Hence, when you are talking about two-tailed, you consider both. Whereas if you are talking about one-tailed test, then you consider probability of going only in that extreme. So here or here. And then this p-value thing is equivalent to your test criterion based on the what do you call table value of the tabulated value of the test statistic. Okay, so what you do there, let me try to draw another picture because this has become quite messy. So in BSc, what did you learn? If this is your null distribution under H0 and suppose this is your tabulated value of the test statistic, then in BSc you used to use a criterion that if you're, let us talk about one-tailed only for the time being. So you used to say that if tcal is, means tcal means t observed, if the observed value of the test statistic is higher than the tabulated value, then you used to reject or accept. Reject, correct? You used to reject in this situation. So this is supporting your p-value thing, because if your observed value is higher than tabulated, and what is going to be your p-value? Your p-value is going to be probability of getting something worse than the observed or as bad as the observed. So p-value is this probability, correct? Probability of this tail. And how do you get tabulated value? Tabulated value is coming here at this point because this entire probability is 5%, correct? Tabulated value is your alpha, like 95th percentile or 1 minus alpha percentile. So it means that this entire region is 5%, whereas p-value is your gray region. Gray region is subset of the green region. So it means that your p-value is, in this current scenario, in this graph, your p-value will be less than 0.05, correct? On the other hand, if your observed value was here, if your observed value had been here, then your p-value would be this region, entire, something as bad as or worse than the observed value. So p-value will be this purple region, and purple region is a superset of green region. So in such case, in this scenario, your p-value will be greater than 0.05 and you would end up accepting H0. By both the criterion, t observed is less than t tab, hence you accept, or p-value is greater than 0.05, hence you accept. Are you following me? So, hence p-value is probability of getting something as bad or worse than what you have currently observed under H0. So if it is very unlikely, then you say that probably H0 is false, hence I am getting this thing even though it is unlikely. Okay. Okay. So let me stop here. Thank you.